Welcome everyone to another video for pre-calculus. In this video, we are going to discuss about dividing polynomials. So if we are dividing, for example, let's take a number example. So if we are dividing, let's say 17 by 5, then it goes 5 times 3, 15, remainder is 2. So now we can write this 17, which is the dividend, equals the divisor, which is 5, times the quotient is 3, plus the remainder is 2. So we can write 17 equals the divisor times the quotient plus remainder. So similarly, I gave you just that number example because it's easy to understand. So similarly, if we divide any polynomial p of x by another polynomial or by a divisor d of x, then we can write p of x equals d of x times q of x, where q of x is the quotient, and then plus r of x. It's just like 17 equals 5 times 3 plus 2 in this example. So usually, I think you are very used to dividing a polynomial using long division method. But if our divisor is a linear factor like x minus a, then we can actually use a shorter way of dividing a polynomial, which is called synthetic division. And that's what we are going to see the next. So here's an example. We are going to divide the polynomial 2x cubed plus 3x minus 5 by x plus 2 using long division. So when we are using long division, we just take x plus 2 right here, and then we put our dividend here. So 2x cubed plus 3x minus 5, and then we go ahead and divide this. So the process of doing this one is we'll have to put something here so that when we multiply with x, we need to get 2x cubed. So that's 2x squared. So when we multiply with 2x, we get 2x cubed. And then we multiply with 2. So 2 times 2x squared is 4x squared. Now next we are going to subtract. So when we subtract 2x cubed from 2x cubed, so it's 0. Now we don't have a square term up here, so when we subtract 4x squared from nothing, so it's negative 4x squared, and then we have plus 3x and then minus 5. So we'll pull everything down here. Now we'll just repeat the process. So we have to put something here so that when we multiply with x, we get negative 4x squared, so it's negative 4x, and then when we multiply with x, we get negative 4x squared. Then negative 4 times 2 is 8, so negative 8x. And then we do the same thing. We are going to subtract now. So when we subtract, negative 4x squared minus negative 4x squared is 0. And then we have 3x minus negative 8x, which is 3x plus 8x, and that is 11x. And then we have that negative 5. We'll bring that down here, okay? Now again, so we need to get 11x. So we'll multiply by 11. So we get 11x. And then when we multiply 11 times 2, we get 22. Sorry. We get plus 22. Now when you subtract 11x minus 11x is 0. So negative 5 minus 22 is negative 27. Now we have three things here. The first one is this is the divisor. Actually, we have four things. So this is the dividend, this is the quotient, and this is the remainder. So finally we have q of x, or it's the quotient, which is 2x squared minus 4x plus 11, and the remainder represented by r of x equals negative 27. So that's what we got by performing long division. Now what we're going to do next is we'll use a shortcut way to divide this, okay, which is called a synthetic division. So when you're doing this, the first thing that we need to do is we need to write this one in the form x minus a, which means we have x plus 2, so this can be written as x minus negative 2. Okay, so that means a is negative 2. Or the easy way to think about this is we'll find the 0 of this factor. So the 0 of x plus 2 is just negative 2. So that's the number that we are going to take. Okay, we'll switch the sign of this number, another way to interpret that. So we'll take that number. So we'll switch the sign of that number, okay, right here. And then we'll take that number, and then we perform the synthetic division. So first we take this one, 0 of that factor, which is -2. And then what we do is, here we list the coefficient of this polynomial, okay? So if we are missing any term here, so for example, here is x cubed, and then we have x, so we are missing x squared. So for any missing term, we'll use 0 as the coefficient, or we need to write a complete polynomial, another way to say that, okay? So what we are going to do is, we are going to write this as 2x cubed. We are missing x squared, so we'll write plus 0x squared, and then we have plus 3x, sorry, we have plus square plus 3x, and then we have minus 5. So we have cube, square, x, and the constant. So now this is a complete polynomial, okay? So now we are going to copy down the coefficient. So coefficient of x cubed is 2, coefficient of x squared is 0, coefficient of x is 3, and the constant term. Now what we do is, this is how we do the synthetic division. The first term will just drop this down here. So we write 2. Now we will multiply these two. Okay, so 2 times -2 is 4, and then we'll write it here. Okay, so we multiply these two, and then we write that product right here. Now we'll add these two numbers. So 0 plus -4 is -4. And then again, we are going to multiply -4 with this. So -4 times -2 is +8. And then we add them, so we get 11. Again, we do the same thing. We multiply 11 with -2. That gives us -22. And we add them, we get -27. So now once we finish that division, let me rewrite this, okay? So it's 11 here, sorry, it's 11 here. Now once we finish the division, then the last term right here, this is the remainder always. So this is the remainder. And this here represents the coefficient of the quotient, qx. So this is how we are going to write qx, okay? Qx equals, so we are dividing third degree polynomial by a linear or degree 1 polynomial. So our quotient will have the highest power of x squared, okay? Second degree polynomial. So now this is how we are going to write this. So we have 2, that is the coefficient of x squared, so it's 2x squared. Then we have the second number here, -4, so it's -4x, then plus 11. So this is the quotient, and then remainder is -27, which is right here. So see, we got the same result that we have here by doing long division, but this is a little bit easier to handle, and then I think it's faster when you have a longer polynomial, okay, and when we have to divide that. This is very important when you're finding the zeros of the polynomial. So we'll see this again later. Now there's a theorem called the remainder theorem, which says that if a polynomial p of x is divided by x minus a, the remainder is given by p of a. Or if you substitute x with this a, or if you evaluate the function, the polynomial function at a, then that gives us the remainder when we divide the polynomial by x minus a. Okay, so p of x equals x minus a times q of x plus this, the remainder. Now this is divide f of x by that given factor, and then use the remainder theorem to determine f of 3. So again, in order to do the, we'll perform this synthetic division. Here, we'll take the 0 of this factor, which is 3, and then we list the coefficients. So we have x to the 4th, x to the 3rd, x squared, x, and 9. So it's complete. There's no term missing here. So we'll just copy down the coefficients. So 2, -3, 1, 1, and -9. And then we'll draw this horizontal line, and then we'll start doing the division. Okay, so the first one, we'll drop these two down, and then we multiply 2 times, so we multiply this, so 2 times 3 is 6, and we'll write it here. And then -3 plus 6 is 3, Then we write 3 times 3, 9. 1 plus 9 is 10. 10 times 3 is 30. 30 plus 1 is 31. Now 31 times 3 is 93. And then when we add this, we get 84. So this is the remainder of the um, uh, this is the remainder that we get when we divide that polynomial by x minus 3. So this is the quotient. So q of x equals, so we are dividing degree 4 polynomial by a linear, so the quotient will have the highest power of 3. So this is 2x cubed plus 3x squared plus 10x plus 31, and the remainder is 84. Now, by the remainder theorem here, by remainder theorem, P of A is the remainder. That means here, f of 3 is the remainder, which is 84. Now, in order to check this, you can go ahead and check that if you plug in 3 here in this polynomial, you should get 84. Okay, that's the value of the function at x equals 3. So, but using this synthetic division and using the remainder theorem, we can also find f of 3 in this way. So there's another theorem which is called the factor theorem. So this is for a polynomial p of x, if p of a is 0 or the remainder is 0, then x minus a is a factor of p of x. And it's straightforward. So you are dividing p of x by x minus a, and you are getting a remainder of 0. That means obviously x minus a is the factor of that polynomial. So we write that as p of x equals x minus a plus qx, so times qx, plus the remainder is 0, so we don't write it. Okay. So this one is asking us to divide, so we have a function and then it's asking us to show that f of 1 is 0. We are going to use the factor theorem. That means we'll divide this polynomial by 1, and then if we get the remainder 0, then we can say f of 1 is 0. Okay, so let's go ahead and do that. So we'll divide this polynomial by 1. So we'll write 1 here, and then we draw that line, and then we'll list the coefficients. So the coefficient of x cubed is 1, coefficient of x squared is -3, coefficient of x is 3, and then -1. And then we draw this horizontal line here, and then we drop 1 down. 1 times 1 is 1, -3 plus 1 is -2, -2 times 1 is -2, 3 plus -2 is 1, 1 times 1 is 1, and then 0. So that means the remainder is 0, which implies that f of 1 is 0. Now the other question is, it's asking us to factor this polynomial completely using this factor theorem, or this fact, okay? Now, if 1 is the 0 of the polynomial, that means x minus 1 is the factor. So now we can write this polynomial as x cubed minus 3x squared plus 3x minus 1 equals, so the first factor is x minus 1 because 1 is the 0 of the polynomial. Now the remaining factor is this one, okay, the quotient. So remember the factor theorem says p of x equals q of x times x minus a. So x minus a is this one. Now q of x is this right here. Okay, so we can write that as x squared minus 2x plus 1. Now to factor this completely, we have to factor this term, and we can factor that as x minus 1 times, so this can be factored as x minus 1 squared, or x minus 1 times x minus 1. So our factors are just the repeated factor x minus 1 times x minus 1 times x minus 1. So that is f of x. Now let's look at the last example for this section. It says find a polynomial of degree 4 which zeros are -2, 0, 1, and 3, and the coefficient of x cubed is 4. Now if we are given the 0, we can easily write the factors. Okay, so let's go ahead and say our polynomial function is, our polynomial is, let's say, p of x equals, So if the 0 is 0, then the factor is x minus 0 times if the 0 is negative 2, then the factor is x minus negative 2, which is x plus 2. The other factor is 1, so it's x minus 1. And the other factor is 3, so it's x minus 3. So these are the zeros of our polynomial. And also we might have a coefficient here. So for that we are going to put a coefficient of a here, okay, just a constant. Now let's go ahead and multiply this. So that gives us p of x equals a times, so this is just x, so we can go ahead and multiply. So this is x, okay, the first one is x minus 0 is x, so if we multiply here with this term, so we get x squared plus 2x. And then let's multiply these two. So x times x is x squared. X times negative 3 is negative 3x. Negative 1 times x is negative x. And negative 1 times 3 is negative 3 is positive 3. Now this can be written as p of x equals a times, so this is x squared plus 2x times, so this is x squared minus 4x plus 3. Now let's do the multiplication again here. So x squared times x squared is, so let's write this way, p of x equals a times. So x squared times x squared is x to the fourth. Then x squared times minus 4x is minus 4x cubed. X squared times 3 is plus 3x squared. Then we have plus 2x cubed when you multiply by 2x minus 8x squared and then plus 6x. Now let's go ahead and combine the like terms. So we have x to the fourth, and then we have negative 4x cubed and positive 2x cubed. That gives us minus 2x cubed. And then we have 3x squared and minus 8x squared. So that gives us minus 5x squared. And then we have 6x, just 6x. So there's no another x. So just that one. Now, if we multiply by a, we get p of x equals ax to the fourth minus 2ax cubed minus 5ax squared plus 6ax. Now, this says that the coefficient of x cubed is 4, and the coefficient that we have for x cubed here is negative 2a. So, which means negative 2a equals 4. And then if we divide by negative 2 on both sides, we get a equals negative 2. So the value of a is negative 2. So that means our polynomial is p of x equals, if a is negative 2, then that's negative 2x to the fourth. Now if a is negative 2, that becomes plus 4x cubed. And then if a is negative 2, that becomes plus 10x squared. And then if a is negative 2, that becomes minus 12x. And this is the polynomial as asked by the question. Okay, that's all for this video. I'll see you again in the next video.